let me ask you something. And seriously, take a second and think about it. How healthy are you? Like, really healthy? Yeah, you might feel okay, you eat your veggies, but what if there's this hidden world inside you, a massive, invisible operating system that holds the real answer? Well, today, we're going to dive into the science that's finally learning to read that code. Okay, so picture this. You get a text message, and it just says, David, you are the red dot. That's it. And it comes with this chart, this scatter plot of dots, where every single dot is a person in a health study. And way off by itself, there's one single red dot. That text? It was from immunologist John Song, and it was for a journalist named David Ewing Duncan. It meant he was a total outlier, but was that a good thing or a really bad thing? That's the mystery we're starting with. So let's really get into this, because David's story, it's not just about some cryptic text. No, this is about a future where one single number could tell you more about your health than, well, pretty much any test you've ever had. We're talking about a sneak peek into the future of medicine, a future where we stop guessing and we actually start knowing. And you know, the guy at the center of all this, David Ewing Duncan, he's the perfect guide for us. This man is basically a professional human guinea pig. I mean, for over 20 years, he's been testing everything on himself. He was one of the first people to get his DNA sequenced. He's had his microbiome checked, his proteome analyzed. You name it, he's probably done it. But even he said that no test he'd ever taken promised to reveal more than this one. All right, so let's start unraveling this whole thing. First up, the red dot mystery. We're going to figure out what that dot actually means by digging into the science of something called the immunome. So, the immunome. You've probably heard of the genome, right? Your DNA blueprint? Well, this is different. A whole lot different. Think of the immunome as your body's hidden operating system. I mean, it is just this vast, invisible network. We're talking 1.8 trillion cells, plus who knows how many trillions of proteins and molecules all buzzing around, constantly working. This is the system that fights off viruses, hunts down those rogue cancer cells, and yeah, it pretty much dictates how well you're going to age. It is absolutely crucial. And yet, until right now, it's been almost completely invisible. And here's what's so wild about it. Your immunome, it's completely 100% unique to you. It's like a living diary of your entire life. Sure, your DNA plays a part, but it's also shaped by every single cold you've ever had, the air you're breathing right now, the food you eat, how old you are, even stress and trauma. It's this dynamic, constantly changing system that's always adapting. It's basically telling your life story moment by moment. Okay, so that's the big question, right? How on earth are scientists finally learning to read this incredibly complex system? That brings us to our next section, and trust me, this is where the real breakthrough happens. You know, for decades, the best tool doctors had was something called a CBC, a complete blood count. It's pretty basic. It's just a head count of a few types of immune cells. But what John Sang and his team are doing, it's a total quantum leap. Instead of just counting cells, they're looking at up to 1 million different cells and biomolecules to see what they are actually doing, how they're talking to each other, how they're reacting. It's like the difference between just seeing a crowd of people and actually hearing the conversations happening inside that crowd. So, how do they take this just absolute mountain of information and turn it into something we can actually use? Well, it starts with a simple blood sample. That gets fed into these super advanced sequencers. But here's the magic trick, step 3. They use AI algorithms to sift through what the source article calls a crush of data. I love that term. The AI basically learns what a healthy immune system looks like and what a stressed one looks like by comparing your data to thousands of others. It finds these super subtle patterns a human could never spot. And then, out of all that insane complexity, it spits out one single number, the immune health metric. And this chart really shows you the power of that one little score. So in their first big study, the researchers saw what you'd expect. People who were already diagnosed with a disease, they generally had lower scores than the healthy people. Made sense. But here's the kicker. About half of the people in the healthy group had scores that were actually down in the sick group's range. What does that mean? It suggests their immune systems were already battling something, a hidden illness, maybe just the wear and tear of life, long before they had any symptoms. This is huge. It could be a complete game changer for finding diseases early. But look, this is way bigger than just one lab or one test. So for our next section, let's zoom out and look at the massive global effort that's underway to map the immunome for everyone. Yeah, something this big doesn't just happen overnight. This has been in the works for more than 15 years. It's all built on the shoulders of pioneers like Mark Davis at Stanford. He was really the one who first started thinking about the immunome, not as a bunch of separate parts, but as one single connected system. And that early research, it basically laid the groundwork for everything we're talking about today. But why do they need to go global with this? Well, here's a perfect example that John Sang gives. There was a malaria vaccine that in trials in Maryland worked great, but when they took it to Africa, it was only effective for about a quarter of the people. And you have to ask, why? The answer is they're immunomes, shaped by a totally different environment, different genetics, different food. They were just fundamentally different. So the lesson is clear. If you want to make medicine that works for everyone, you need data from everyone. And that is the exact mission of the Human Immunome Project, or HIP. And when I say the scale is massive, I mean it's staggering. We're talking about a goal of around $3 billion. A 10-year timeline. They want to collect data from 250,000 people at 150 different sites all around the globe. The end goal? To create the first ever comprehensive map of human immune diversity. Okay, let's bring it all back to where we started. It's time for the big reveal, the moment of truth for our experimental man, David. What did his score actually say? And more importantly, what does this all mean for the future of our health? All right, so the red dot, the big mystery. Why was he such an outlier? The first number came back from the lab. It was 0.35. And John Zhang explained that this score put David's immune health, get this, right in the middle of a bunch of people 20 years younger. Imagine hearing that. It was a huge relief. He was an outlier, but in the best possible way. And then, as if that wasn't enough, a second result came in from another lab. A collaborator named Shai Shen-Or used a totally different method to calculate David's immune age, and the number was 57. Now, keep in mind, David was in his late 60s at the time. So again, a full decade younger than his actual age. The good news was confirmed. That red dot wasn't a warning sign, it was a badge of honor. But David's reaction was interesting. He was relieved for sure, who wouldn't be? But he was also a little bit disappointed. He was hoping for these really specific answers, like, okay, so why did I get long COVID? The score couldn't tell him that. And I think that's a really important takeaway here. This science is still so young. The score is an incredibly powerful snapshot of your health, but it isn't the full movie. At least, not yet. So, let's talk about the big picture. Why does this matter for you and me? Honestly, the potential is just enormous. We're talking about the real possibility of detecting diseases like cancer before you ever feel a single symptom. We're talking about creating vaccines that are personalized to your unique immune system. And yeah, maybe one day you'll be tracking your immune score on your watch or your phone, right next to your heart rate and your daily steps. And look, this isn't some far-off science fiction dream. A clinical immunologist, Dr. Rachel Sparks, says she thinks that within a decade, just 10 years, this kind of technology will be in the doctor's office. Can you imagine? Doctors could use this super detailed, granular understanding to target treatments with incredible precision, going after the exact cells or pathways that are causing a disease. So we kind of end right where we started, with you. Your immunome is this living, breathing, constantly changing record of your life. It knows the truth about your health today. And as this science gets better and better, it might just be able to tell you a lot about your health tomorrow. So the final question is, if you could see your score today, what do you think it would tell you?